Welcome, everyone. It's my great honor to introduce Daniel Yuschick from Finland.
Yes, thank you so much.
Give a warm welcome.
Yes, hello. Got ourselves a hell of a turnout here. This is awesome. Good morning. Welcome to NDC. Feels really cool to be an early talk here in the morning. And I'm super excited to be talking about one of the main problems that have been plaguing software development for at least a decade or so now. And ultimately that is, how do we componentize our UIs and our designs? A point I'm going to be harping on all day today is that content will forever and always change. So how do we build our components inside of our code bases, whether it's a UI library, component library, or a full-blown design system? How do we ensure that we can build our components to scale and grow with those changes to provide resiliency to our products? This has been an area I've been most interested in for probably the past 10 years or so, but I've worked in the front end for another 16 or so. To give you an idea, my first job title was as assistant webmaster. Assistant to the webmaster, depending on who you asked. But during that time, I spent a lot of time working as a designer as well, and kind of sitting in that weird fence right in between not being designer enough to be on the design team and not being techie enough to be a developer, because I grew up writing HTML and CSS. But that led me to a passion for UI, UX, and accessibility, which led me into the realm of design systems, where right now I work as the lead design systems developer at Posti, which is the lead, or is the National Postal Service of Finland. We are branching out into Sweden, Norway, so really exciting to work on something at that scale. But during these years, all the different code bases and this project in particular all suffer from very, very, very common patterns that tend to break down over time. And when your components break down and do not accommodate for changing designs, changing products, you hurt the trust. Hurt the trust across teams and hurt the trust throughout an organization. The amount of times I've been told it's easier to just build it myself than to use the actual component library. It's kind of like a dagger to the heart, because that is at the core of why we're trying to build design systems and libraries, to help make development and design work easier. And if we're not doing that, we're failing. So today we want to look at what are those component patterns that break down and fail over time. Again, content always changes. How do we build our components to be resilient to that change? Then we're going to look at alternatives to those patterns that tend to be more resilient over time, easier to manage, and easier to learn and understand as a consumer of that system. Now, worth noting, the code samples we're looking at today will be done in TypeScript and React. I believe the concepts are generally universal, though. People who know Svelte or Angular or Vue or something else might know a little bit better than I would, but those are at least the code samples that we'll be looking at today. We'll first be starting with our interface management. How do we manage our TypeScript interfaces? These are the entry points to our components. This is how we use and interact with these components as these consumers. So how do we make sure our interfaces are resilient to these changes? And then we're going to explore a component pattern within React about not the entry point of the component, but how do we actually manage and architect the component itself to solve problems that tend to pop up when developing some of these components. I'm going to throw a lot of stuff at you. We'll do a quick recap at the end. All good. And then one last thing. This is probably a stretch, but does anyone here know the TV show Psych? We got a few. Okay, this is the most hands I've ever seen. Okay. Favorite TV show ever. 8 seasons, and in every episode of every season, there is a hidden pineapple. So in lieu of my love of Psych and mourning its departure from Netflix, I've hidden a pineapple in these slides today. So if you are the first person to find the pineapple, shout, get my attention, stand up, you will win a prize. You can collect it after the talk because the stairs are really steep and I'm scared of someone falling. So whenever you find the pineapple, stand up, shout, do something, get my attention, and...
Right there. Pineapple!
Pineapple! Not this one, there's always one. I'm a developer. I know how we think. All right, so all the housekeeping stuff's out of the way. I think we can jump straight into our interface management, and ultimately, how do we make the most out of our component APIs? We're going to look at a few key points here, and the first one is just called grouping similar props. Pretty straightforward, but you'd be surprised how much this can benefit our work. One thing to note here as we look at this interface for an input component is that unless I tell you otherwise, every code sample you see today will have been taken from a live production code base. As terrifying as that may be at times, this is live production code we're looking at, including this interface. Now granted, this is a subset of the folder input interface from this component, but I wanted to highlight these 5 specific properties because they highlight a pattern that tends to rely heavily on Boolean attributes, Boolean properties, and these tend to be the most prone for bloating and blowing out an interface and making it difficult to manage. Where we have 5 properties here on our interface to essentially manage 3 kind of categories. We have properties regarding the label, kind of the mode or theme, and the size of this input. Yet, if we need to introduce maybe a different size or a different theme, the pattern here is just to add another Boolean property to this. And if we need to add another, like another theme or another label type, this interface becomes very unwieldy and very difficult to manage and very difficult to learn as a consumer. So instead, we want to group these props into these categories. And we want to leverage these union types in TypeScript to create categories of these characteristics of our component. So instead of having numerous Boolean properties, we're able to have just 3 categories relating to the label type, the theme, the mode, whichever you want to call it, and the size. Which seems pretty straightforward, but where this really shows its benefit is when you need to add a high contrast theme, or you need to add a different size. Whereas before, with our Boolean properties, you would end up having an extra Boolean property now for the is high contrast theme or for the additional size. And ideally, you would probably have to go through and start having some defensive conditional checks in your types to say, hey, if is small is true, we also have to make sure that is large isn't true. And if light mode is true, we also can't have high contrast to true. You create this extra work just to kind of check to make sure that you're using properties in the correct way. Whereas when we're using our categories this way, we're able to introduce new features and new variants without causing issues with defensive conditional checks. We can just add the support for the high contrast theme, add that value into the string literal union type here, and now we don't have to worry about sort of cascading issues outward. We're able to add this theme to our component and not really bloat or complicate the interface. It's just adding one more value to that category. So when we add our categories, we're able to kind of group these props together, group our characteristics together to make this component interface easier to manage and easier to step into and easier to expand as products change. And it's not just inputs. We can look at this with the button, kind of like pretty much where every system wants to start is the button component. And we could see how these categories can affect a button interface as well, where, again, we can have different categories for how it fits. Should the button fit to fill its container? Should it shrink to hug its contents? We can easily manage multiple characteristics and traits of our components by grouping them into these categories. And this allows us to, again, more safely add features and add variants without adding complications to legacy code base or legacy products that are using these components. There's another way I like to look at it, because our components, like I said, content always changes. Our components have to kind of change with those, and it's really easy to build a component in kind of a small, isolated thing and think that it's just going to stay like that forever. how I like to think about this is New Kids on the Block. They happened. Amazing. They started a whole thing. So much so that Take That in Westlife happened. And now we're thinking, okay, getting a little out of hand here. It's fine. Until it wasn't. When Backstreet Boys and NSYNC, my personal favorites, popped onto the scene, and then that just created the snowball effect of the 98 Degrees, LFOs, O-Towns, and frankly, a lot of others that it's tough to find gifts for. They didn't quite make that level. And then we had, O-Town, which led way to BTS, who took over the world. So while New Kids on the Block started something and it seemed like boy bands would be kind of a small, isolated little thing, it very quickly grew to be an unwieldy network of artists and musicians. So our components can kind of scale and become unmanageable in the same way. I think the boy bands is a good example of this happening. Components not so much, because it becomes very difficult to do your job. But there's another example of how we can group common component property patterns into an easier way to manage. And in this example, we have again, the input interface, and we have a has error and error message property. You see this a whole lot as well with icons, where you have a has icon prop as well as then the icon kind of property itself. And I couldn't really find like a really good name for this. I couldn't really find how this is referred to. So I look at it as the data gate model. We have the data of error message in this case, but it's locked behind the gate of has error. So it seems like this is a very common pattern that we have. We see this with error messages. We see this a lot with icons. We see it with help text, tooltips. We see a lot of two properties kind of managing one thing. So in our code, we might end up looking at something like if has error is true, now let's render the error message. Of course, you probably want to also have a check to make sure that error message exists. Not always the best at writing error messages, so we might want to make sure that that actually exists, and then we can toggle our aria invalid attributes and kind of manage our states that way. But like I said, we're kind of taking two props to manage one thing. We just want to know, is there an error? And we can instead do that by just asking, is there an error message? Is there an error message? Is there an icon? Is there help text? Is there a tooltip? We don't need two props to do this. We can just take the separate data gates and just form them into one prop. And that way, if error message exists, we should be able to trust that the input is in an error state. Why else would we have an error message than if we're in an error or invalid state? Same thing again with icons. If we pass an icon into the component, really good chance we want to render it. Really good chance we want to render it. Right, so we can, instead of having two props, a data and a gate prop, to manage one part of the UI, we can just combine this into one prop, check in this case if error message is truthy, and then render that, as well as then toggle our aria invalid attributes and toggle our CSS selectors based on that to actually display the input in its invalid state. So those are a few ways that we can group props, multiple props. Like I said, the most frequent culprit of this are Boolean props. They're the easiest ones to blow an interface out of proportion. We can group those multiple props into categories or into, in this case, a single data gate prop and manage our interfaces a bit more easily with more forward flexibility. Which introduces then our second key. This is where I would normally say this is my favorite of all the keys, but like this is the stuff that I spend far too much time thinking about. The amount of time I've just rambled to my wife about component architecture, unbelievable. Like all of these things are my favorite parts of this talk, of components. This is where I love putting thought and effort and planning into. But consistency is key. This might be maybe 1A of my favorites. Because if you know how to use one component, you should know how to use the others. If you know how to use one component, you should know how to use the others. Like I said, I'm working on a design system for a pretty large organization with multiple brands, quite a few additional partners. And we have a system of maybe like 50, 60 components. But at least right now, kind of how you use each component is different. And this is why we get feedback about, hey, it's easier to just build the component ourselves than to try and learn how this component works, because there's also no documentation about it. So part of my job is to take the keys and everything that we're covering today and define those as our principles of the system as a whole to sort of govern all of our components. It doesn't matter if it's an older component or one that we build in the future. We will have a set defined role of principles that say, if you know how to use one component, the conventions used within that component, you will be able to apply those same conventions and be able to know how the other components work as well. Let's take a look at the button and switch interfaces here. Now, both of these components have the ability to be shown in a loading state, like being busy. They can both be shown as disabled, and they both have different sizes. Yet they do all three things in different ways. Now, this is super common. Super common. Both of these code samples were taken from the same code base. So let's say I'm at a company, I build the button component, and then I leave. A new developer comes in, and they build the switch component their way. Maybe I didn't document the conventions, so they build the switch component the way that they would like to. Maybe I did document the conventions, and the new dev just doesn't give a shit. Right? Maybe you're part of sort of an ad hoc design system team, and you're accepting contributions of the button and the switch component, but there's no real strict governance over the conventions and patterns used when contributing into the system. This is common when you have ad hoc teams, not a dedicated design system team, but just sort of people who review PRs once in a while for the greater good. So I'm trying to explain here is that this is very, very common and not necessarily anyone's fault. There's a bunch of situations and environments that lead to this happening. But what we want to be able to do is say, if we have conventions that apply to the button component, and we know how to use the button component, we should be able to kind of instinctively understand how some of those conventions and patterns work with the switch component as well. And where we want to start with that is how we name our properties themselves. So we have the button and switch component here, but I've now also introduced the icon component, just to show that this doesn't pertain to just interactive controls. These same conventions can apply to visual UI components as well, like the icon. But what we've done here now is we've standardized the component properties. So now we've settled on one set of conventions that says we're going to use the isBusy term to manage any loading state of any component. We're also going to use the whole is, has, show, with kind of Boolean naming convention. We're going to use isDisabled to manage our disabled states, and we're going to use the 2-letter t-shirt size to manage the sizes of our components. So again, when you sort of see this, it maybe doesn't seem like much until you see or work with a library that doesn't have this. And then you're like, something feels off. But when we have these shared conventions like this, you can start to use the button and the switch, feel fine, but now you need to use an icon, and you can reliably trust that that icon has a size property, that its values will also be the 2-letter t-shirt sizes. It doesn't matter if it has an XS size that the button and switch do not have, because you're going to follow the same convention for both the property names and the property values themselves. There's a consistency across the entire code base. But this goes beyond just property names and values. This extends to the defaults as well. We've gone through, we've updated all of these interfaces that say whenever you have a size property on any component, that size property will always default to medium. I've worked in code bases in the past where you would have just the standard button component have a default size of medium. Great. So then I go to use the toggle button component, and its default size is small. Now I have to learn how both the button component and the toggle button component work individually. That's that's quite a cognitive load if you have 40, 50 some components. So you want to define these patterns and these rules, these principles. In our system at Posty, we refer to it generally as terminology. We define a global set of terminology of how we refer to properties, what they mean, and what their defaults are. And we say anytime a component has a size property on it, it will default to medium. And I think it's an important thing to note that we're not learning the convention, or like we're not learning the components themselves. We're learning the conventions that govern them. I may have had two-letter t-shirt size examples up there for the sizes. I may have had is busy and is disabled. It doesn't necessarily matter what your convention is. You don't have to copy the code from these snippets. But what matters is that there is a set of conventions that if you use the size prop, you want to make sure that it defaults to the same thing so that people using those components, people using that system, will be able to trust that anytime a component has a size, it defaults to the same thing. That if you have any type of control or button or interactive element that can be in a disabled state, you're going to handle that disabled state the same way. We're not learning the individual components. That's a lot to ask. Instead, we want to learn the one set of conventions that governs all of them, old and new. So we're not learning the components, we're learning their conventions. This does go beyond just development, though. We've been talking this whole time about development consistency, but we also have to ensure we have consistency and collaboration between development and design. So this is a code snippet that I just made up just to fit this narrative, so full disclosure. But I feel like I've built something like this in the past in Storybook, where we just have different groups of an input next to a button in our different sizes. So the first set has a small input next to a small button. Then we have a medium input next to a medium button, then large input next to a large button. We should be able to trust that components that are using the same properties and values also create consistency within the UI and the design. That if we're creating a full form and it has separate text fields, has a submit and reset button, it has a drop-down text area, has all these things. If you set all of those form fields and controls to the same size or to the same variant or to the same mode, that you're creating a UI that is consistent and unified as well. Now, this takes collaboration with design to make sure that you're actually in sync and aligned. You have to collaborate and you have to communicate with this. But having consistency on the code side isn't enough if it doesn't render a UI and a design that is also consistent and unified. So we have to make sure that we collaborate across teams to ensure consistency on both the dev and design side, which results in a consistent UI and product experience. So when we actually render that code, we will see that we have an input next to each of the buttons, and everything seems fine. So when we collaborate, we get the consistency at all levels of our product, and we build that trust, that reliability. It's not just resilient components that can evolve with change. It's about building that trust and that reliability when using the system. We all know when we're using a product if it feels stable. We want to make sure that what we're releasing feels stable to its consumers. So consistency is key, which leads us to our last point in the interface section here, which is don't reinvent HTML. Definitely 1B in terms of favorite things ever. Like I said, I kind of grew up writing HTML and learning CSS. I know it's such a noob thing. I'm not even like a elite dev or anything. But there's a lot of front-end devs who don't seem to know much about HTML, and it makes building components very challenging. Because every time that we deviate from a standard HTML convention, that's one more nuance that we have to remake as developers. But then as consumers, you also have to relearn how that new convention works. So we want to leverage that shared knowledge, that shared experience of HTML whenever we're building our components. HTML has been worked on for decades by a huge group of people. Why am I going to try and change what they've done or reinvent what they've done just for the browser then to change its support and now I need to evolve with it, right? So every time we deviate from HTML. It's a nuance that we have to remake as devs, and a nuance that we have to relearn as consumers. I'm going to pick on the input component again. Because let's say you start a new project and you get this as your design. You know, just a few different states. You got disabled and error states. So you create an interface, and you add a few properties there, and you think, all right, great, we did it. We can now create this input with this interface, ship it. But content will forever and always change. So then 6 months later, it does exactly that. And now we need a bit more flexibility within our input component. We need some different types and some different sizes. We now need kind of support for different slots and stuff as well at the ends. And now our component gets a little bit more complicated. Oh, I think I got you first. You're close enough. I can hand you your prize. He wins finished chocolate. Give him a round of applause. Yes. There you go. Yep. Awesome. Astute. Okay. So now our input component has changed. We now need to support more variants, more sizes, hint text, all that stuff. So we now adapt our interface. So now we're getting a little complicated there. We're having support for autocomplete and all that stuff, and it starts getting a little hairy. And then it gets really hairy. I'll remind you, every code sample in this talk, unless I tell you otherwise, has been taken from a live production code base, including that thing. So when I step into this code base, I'm asking, like, tell me why. How did we get here? How did we end up in this position to have an interface like this? Because I don't want to work on this. I don't want to use this. Nothing about this is usable or good to the overall system. But we got here for one very key reason, and is that we did not handle HTML attributes separately from the component props. We want to treat HTML attributes and component props as two separate things. HTML is already there. It's a native thing. The browser supports it. Like, it's already there. We don't have to reinvent that. We want to have our interfaces simply manage the props that manage and customize and control our components themselves. So we want to treat HTML attributes and component props as two separate things. Now, in the world of React and TypeScript, we can refactor this input component to extend the native HTML input attributes. This will give us access to things like autocomplete and type and max length and min length and required and placeholder. It gives us access to all of these attributes, all these callbacks, all these events. It gives us access to everything out of the box. So we're now able to greatly reduce the size and complexity of our interface by extending the native HTML attributes this way. And then our interface just contains the props that are custom to our component itself. So when we extend the native HTML attributes, we also now have access to the ARIA invalid, ARIA described by, ARIA error messaging, all of the attributes that we need to ensure that we're releasing and shipping accessible experiences. We have those all out of the box. And it doesn't matter if HTML changes, adds a new feature, like if it adds a new inert, or has a recent hidden until found feature. You get these out of the box. You don't have to recreate these every time, and then you can simplify your interfaces to focus solely on just the props that are required to customize and control the component itself. So we're going to look at another button example here, because this, of all the common patterns I see, this is top 2 most common patterns I find that break down over time. And it's a button component that has a text prop. Maybe you call it message, label, something else, content. But it's a prop that's typed to be just a string. And I get it. If you just have a text prop on the button, then you can't risk someone passing in, I don't know, a link or an image or something like that into the button and creating some crazy inaccessible experience, some crazy unbranded color or something like that. It feels like you have this sense of control over what goes into that button, because now you can say it's always going to be a string, And we're always just going to have the color be the branded color that we specify. And that's great until it isn't. And design comes back and they say, all right, well, hey, we now want to have a new loading state for these buttons. We want to have the text be italicized when it's in its loading state. We want to have the nice incrementing button pattern. So you think, okay, that gets a little hairy. Maybe we introduce a new like loading text prop, and then we have different styles applied to that. Maybe we kind of scrap this, create button v2, and support this in a different way. But now we have a whole lot of technical debt. We have a separation in our code base between our button components. Maybe, and I've seen this, maybe we just take the styles from the button component, copy them, paste them into our one button component, and it's just a random little snowflake over here that looks like it's using the system, but it's not, until you try and make a change, and you're like, why isn't it over here? But we got to this point where this component breaks down because, again, we deviated from how the native HTML buttons work. And at this point, I would like to get some opinions from y'all as well. So in the context of HTML specifically, what is a button? Feel free to shout out. What is a button in the context of HTML? An element container, right? Okay. Okay, yep, okay. Anything else? An interactivity, okay. Let's take one more. Yep. Input. Okay. Okay, cool. So we have an element, interactive input. Okay. I think that pretty well checks a lot of the boxes here. I see an HTML button as an interactive semantic container. An interactive semantic container. You have the semantics as part of it, because the button will render to the accessibility tree its role, its labels, its context. You have the interactivity because you're able to click on it, you're able to tap on it, you get the tab stops and focus states and all that stuff. So you have the interactivity built in. But the key point here is the container aspect. In HTML, you can put anything you want inside of that button. Doesn't mean that you should, but you can, and that's the beauty of HTML, that it gives you just enough flexibility and freedom to shoot yourself in the foot. So whenever we're creating our button component, an abstraction of a native HTML element, we want to make sure that we follow the same native HTML conventions. So in this case, if the native HTML button is just a semantic interactive container, why are we doing anything different? The HTML button doesn't support a text prop. Why do we need a text prop? Because I already know how to use a button in HTML. Why is your button different? So when we update our button component here to just extend the native button attributes in HTML, this includes children in the context of React. We now have a button component that looks and feels and works like the native button element itself. So if you know how to use a native button in HTML, you can instinctively know how our button works as a component within our system. There's not this deviation, there's not this nuance that you have to learn about our button being special. I know everyone's buttons are special, but they don't have to be that special all the time. Right, so when we follow native HTML conventions and we don't try reinventing HTML within our components, it's an easier thing to learn, it's an easier thing to use because we have a native shared understanding of how buttons and a lot of elements in HTML work already. Now, other astute observers may have seen another thing in our input component that would have caused problems. And I want to focus on the specific onChange handler. Maybe this is on click, maybe it's on input, maybe it's on something else. But with this, we're going to focus just on the onChange handler. Now, I just built a text area component yesterday, and I just had to refactor this exact thing, where we have an onChange handler within our input being redefined within the interface. And we notice that we're just passing the value within this handler now. Normally, whenever you have an onChange event handler in JavaScript, you get the full event. Now, 7 times out of 10, You're just going to write event.target.value, and that's great. So I've seen a lot of times in a lot of systems and a lot of code bases where developers try and get extra fancy with it, and they just pass you the value itself directly. But that's going to break down, because 7 times out of 10, you might just need that value, but the other 3 times, you might need a class list. You might need to be able to set or toggle an attribute. You might need access to its sibling or a parent. And if you no longer have access to that full event object, you're now stuck. Do you update this onChange handler to have value as a string or maybe an event? But then you probably need to go through all the code base and cast all the uses of value to be as a string. So that's complicated. Maybe you introduce input v2 again, and now you have that deviation and separation again. Maybe again, you go the route of just copying the styles and creating a little snowflake input over here. None of those options are good, as it's going to lead to a lot of technical debt to manage, and all of that technical debt is caused from deviating from the native HTML conventions that we should already be familiar with. So again, with this input, we just want to update this to extend the native input attributes. This includes your event handlers, like onChange, onClick, anything else. And that will send you just the event. So boohoo, 7 times out of 10, you have to write event.target.value, get over it. Because the other 3 times, you're actually not having to break things down, you have access to the full event, and you can treat your input component like a more native experience. Whenever you're creating these native abstractions of native HTML elements, we want to be sure that we're not reinventing HTML as we go, and we're following those conventions that have been defined and refined over decades. Now, as I said, at Posty, I'm implementing these as core principles of our entire system to govern it moving forward. I think they can all live side by side in unison and create a reliable, resilient architecture. As we've been doing our migration and implementing these patterns, we've been able to kind of say goodbye to really complicated user interfaces or component interfaces. And we've been getting feedback from our users already that say, hey, this feels better. Our adoption metrics, although slightly, are starting to tick in the right direction, because we're having more resiliency and reliability within our interfaces. So eventually, in maybe 2 to 3 releases, we're going to be able to say goodbye to all of those old interfaces that didn't have consistency, tried reinventing HTML, and just had a flurry of Boolean properties blowing out the entire interface. We're going to be able to say goodbye to those ones. I guess if I'm staying on brand, I don't know, we're going to be able to say bye, bye, bye to them. So that's our TypeScript interface management section. Like I said, I have one more thing I want to go through, and that's a React-specific pattern that, again, maybe people with Vue or Angular experience, there might be something similar-ish. If it's in Vue, it's probably a lot easier. But what I want to look at, I call component stores. Now, I saw this convention in a system called Aria Kit. And I'm not saying they did it for the first time, but they're the first ones I saw do it, loved it, took it. Now I'm speaking about it like it's my own. Classic developer. Component stores allow you to keep a single component in sync across multiple files and multiple parts of your UI, which feels a little abstract. But where I really saw this come to play was when I was building a popover menu. At the time, I was working at a gaming company. We were doing like gaming, streaming stuff, and we had a very, very heavily interactive platform that was very game-like. And we had popover menus that would sometimes be triggered from an icon button this way. Doesn't matter what the icon was, could be anything. Sometimes it was triggered from a full traditional button. Sometimes it was triggered from a link. Sometimes it was just part of like a tooltip kind of thing. We used popovers a lot. So we needed a component that supported those various use cases. Now, a lot of times, I see popover menus just ship a popover trigger element. But we really couldn't do that because we had a lot of complexity and a whole lot of variance to what our popover triggers were. What did you actually interact with to open and toggle this popover menu? And this is where the store really came into play, because what this concept will allow us to do, and we're going to look at some code to kind of break this down, is it allows you to create a centralized store And within this store, we're able to manage everything like our ARIA associations between the trigger and the popover menu. We're able to manage the focus and tab stops within this popover menu. We're able to manage the actual open and close toggle states of the menu. We can manage the placement and positioning, the anchoring of the popover menu. And then once we get this store result from this use popover menu hook, we can now pass this to both a random button, icon button, link, whatever the trigger element is for the popover menu, and then we'll pass it to the popover menu itself. So we create one centralized store with all of the logic, all of the information that we need to manage and run and maintain this popover menu. We take that and we send it to whatever we want to be as the trigger element and whatever the actual popover menu is itself. It doesn't matter if these are in different files or in different parts of the UI. We can keep them in sync with one unified store. And in practice, it looks a little bit like this, where we just have a really straightforward React hook here called use popover menu. And like I said, inside this hook, we can kind of abstract away a lot of the accessibility considerations that would need to be made, a lot of the internal management of like the state of the popover menu, its placement, its anchoring, all of that stuff. Because what I find is if I don't kind of hide and take care of the accessibility stuff behind the scenes, I can't really trust that a component as interactive as this will be implemented accessibly. So this gives you a chance to kind of hide that behind the scenes, and then the consumers just sort of get it a little bit for free. You kind of make the accessible adoption of these components a bit easier. So it looks maybe a little bit more like this, where we manage the open and close state of the popover menu, but then that store, the critical store, is what we return from this hook, and that is this object containing actions and state. State might be a confusing term here. This is a personal preference. Maybe you want to call that data. More recently, I just have the actions group that handles all of my handlers and actions like this, and then all static data is just a sibling of that. I don't group that anymore. But ultimately, this object that we return from the hook is that centralized store that manages our state, our placement, our accessibility, and all of our ARIA associations required for ensuring that our trigger and popover menu remain in sync. So then this is a mess. We're going to break this down a little bit. So in React, we would first instantiate that hook. We would call use popover menu, and we would save or store its return value as our store variable. So now in this case, our store variable equals that object of actions and state. So now that we have our one centralized store, we can now go to this icon button that may be in a separate page, maybe in a separate file, and we can pass in that store to its onClick handler and say, all right, whenever onClick, we're now calling that store.actions. We're calling the action within that centralized store. And then we also pass in that ref to make sure that we can associate all the ARIA associations and make sure that whenever that popover menu closes, we move focus back to this trigger. So we create that action for opening and closing the popover menu within our hook, return that within the store. We create that trigger ref within the hook, return that within the store, and then we pass that to our icon button to associate it with that instance of the popover menu itself. And then we just pass the whole store into the popover menu. So now the full popover menu knows everything about itself. It knows when it should open and close. It knows what its trigger element is. It can be associated with it. It can return focus. All of that great stuff, because that's all done behind the scenes within the hook. So we're able to create one centralized store with actions and state and pass that to an icon button that might be in a header, but a popover menu that might be somewhere else in the code base. And we're able to have dynamic triggers opening and closing the popover menu while retaining that sense of accessibility, because we can manage all of those associations and logic behind the scenes. Now, we've been looking at component interfaces up until this point, and I like the component store approach because it can sort of double as the same thing. up until now, we've been looking at passing props into a component. But what I like to do is actually use these hooks, particularly if they're consumer facing. I like to use these hooks as the entry points into their components. So we would customize the component whenever we instantiate it with the hook itself. So we would take that use popover menu hook, and we would extend it to say, all right, we now support an onOpen callback, an onClose callback. You can define the placement, so you know where this popover menu should open relative to its anchor. And again, we can handle all of this stuff then inside of the hook. The hook will handle all the logic, all the callbacks, all that fun stuff, and then it just returns you that one store object. And you can pass that store object anywhere you need. Let's say you even have like a full popover menu provider that manages all the popover menus at a high level of your app, and now you just log that store into that provider, and now you have access to it at any point within your app. You can do a lot of stuff with this, but ultimately it breaks down to keeping a single component in sync, especially if it's comprised of multiple parts like this, or like tabs, for example. That's another common place where I use this pattern. You can keep a component in sync despite being in different places in the code base and perhaps different places in the UI as well. Like I said, I like to use this with tabs to make sure that we have proper accessible associations between tabs themselves and the panels that are associated with them, which are usually going to be in different parts of the UI or like in different files perhaps. So I like using this pattern for components like tabs, popover menus, tooltips, kind of things along those lines that sort of are comprised of multiple pieces. So that's a lot of stuff. It's a lot of stuff. So I want to spend a quick moment just recapping each of the key points we went through today. We had our interface management principles. First being just grouping similar props. Like I showed, Boolean properties tend to be the most common culprit of bloating and making an interface very unmanageable. But we can instead move a lot of those Boolean properties into grouped keys, grouped category properties on our interface using union types and TypeScript, which also allows us to extend and add new variants or new features with very, very minimal effects or impacts on existing code that are using that component already. Then we went through the importance of consistency is key. We need to ensure that our conventions, that we have one set of conventions that govern all of our components in the system. And this consistency applies to property values, property names, our property defaults, as well as the consistency within the design and the resulting UI of using our components. Then we looked at don't reinvent HTML, and we showed how components like buttons and inputs can break down as content changes if we deviate from these HTML conventions. So whenever we're making components that are abstractions of native HTML elements, it's crucial that we inherit that native functionality and expectation. If we're working on the front end in some capacity, HTML knowledge should be an expectation. And then we look briefly at component stores within React and ways that we can sort of create all of our logic in one central hub inside of a store and use that to keep a component in sync across multiple parts of our files, code base, or UI entirely. I mentioned this a couple times, and we're talking about buttons and inputs and icons and things that are rather insignificant by themselves. But we're not just building components here, we're building trust. We're building trust across teams, within an organization, within a product. Like I said, when we're using something, we all sort of feel when something feels good. Like I was just trying on glasses this past weekend, and I would put on these ones that are like really, really tiny wired frames, and it just felt like these are just going to fall apart. Like I'm going to break these now. Like it's not sturdy. It's not what I want. It doesn't have a good feeling to me. So I try on a different pattern. It feels a lot more stable, a lot more sturdy, and I know when that feels good to me. We instinctively know when something feels good, and we trust when something feels good. So we're not just building components, buttons, icons, anything like that. We're not building anything that really matters at the end of the day. What matters is the trust and the reliability that we build within our system, across our teams, and within our organization through the use of building components. And then one last quick disclaimer. We're all devs, like I said before. It doesn't really matter what your convention is, as long as you have a convention that governs your system. And while I'm implementing all these keys as core principles of our system, doesn't mean you have to as well. So it depends. Take whatever pieces you want, take whatever pieces you need, modify where needed or where you would like. It depends. I think it all works together in a nice way and creates a nice set of conventions to govern the system. You might think otherwise, and that's fine. But as long as you have a set of conventions that manages a larger set of components, you're going to be all good. And with that, I'd like to say thank you so much. Now, we do have time for questions if we would have any. I don't know if we're set up to take them, but I don't know. But I'm going to be here for a while. So if you have questions, feel free to track me down. You can come down and say, hey. And if not, feel free to connect with me on LinkedIn. You can always feel free to message and ask and chat there. So thank you so much for your time. Thank you for your attention. Have a great conference, y'all.